Hi, my name is Muhammad Ali bin Abdullah. My metric number is AE2000002. For our group introduction is power electronic is an application of solid state electronics that control and convert one form of electrical form to another form, such as converting between alternating current to direct current. And a three-phase inverter is a device that transforms direct power input into a three-phase alternating current output. That is for our introduction.
Hi, my name is Nick Ahmad Hakimi bin Zulkifli. I will explain the methodology for this project. So this is the flowchart for the methodology, which is start with DC supply, will connect it to the full bridge inverter before it goes to step-up transformer, and after that it will goes to diode bridge rectifier, and then output filter, feedback signal, and then the final one is the SP control card. So the basic knowledge required for this project is three-phase inverter system. So inverter is electronic device that can be used to change the electric form, which is from DC to AC. So PWM is used to hold pulse width modulation. The delay between the phase is 120 degree because it is three phase. So the switching in three phase system will happen at T equal to 60 degree. So switches work in concert between another, which is will generate sine wave to generate square voltage. So this figure shows the basic functional three-phase inverter system. DC supply will be supplied to the circuit to generate the AC output waveform. So the circuit shows the modified PWM that has been done by this group. So it uses 6 LGBT to control switches to define the sinusoidal line at the power unity factor and plus voltage. So power conversion will happen in the microgrid, which will involve all the 6 switching topologies to make sure the inverters work and provide 6 PWM system. So filter is needed to get the minimal THD, which is 7%. So this inverter is functioned to manipulate outputs utilizing pulse width modulation or PWM technique. So the implemented of PW technique is in the inverter is by altering the on-off period of IGBT's inverter. So this is to enable direct control of inverter output voltage and frequency according to the sign function used. So the SPWM technique is most suggested over any other PWM techniques.
Hello, my name is Lia Maisara binti Abdul Razak with metric number AE20039. So I will explain about the simulation of three-phase inverter for RL load. Basically, in this circuit, we are introduced the SPWM, the three-phase inverter, the filter, and the three-phase RL load. So this is the current and the voltage measurement to see the graph. So basically, in the SPWM, when we run the simulation, we can see that the book will produce the value as a like this is a sinusoidal graph. So we can see from this the sinusoidal graph is referred as a reference voltage, which is referred to the modulating wave. So when we try to zoom in, we can see that there is a triangular waveform which is referred to the carrier wave. As we know that the carrier wave is usually has a higher frequency than the modulating wave. We move on to the three-phase inverter, which were connected to the filter of capacitor and inductor, and lastly it connected to the three-phase RL load. So basically we are using the voltage 480 volt, the inductor is 1.5 millihenry, and the capacitor we use 7 microfarad, and then we connected to the RL load, which value is 14 ohm and 0.3 millihenry as the requirement in the PBL. After that, we run the simulation and we can see the voltage measurement like this. So there is a 3 sinusoidal graph. So when we zoom in, we can see that sinusoidal graph like this. So from this, we can see that the line-to-line voltage is 415 volt with the frequency of 50 Hz. Follow the requirement in the PBL. After that, we need to know the total harmonic distortion for the current and voltage. So we need to click at the power going, then we select the tool for FFT analysis. After that, we select the current measurement and we use number of cycle is 5 with the 50 Hz fundamental frequency. Then we display, as we can see, the fundamental is 17.07 with total harmonic distortion is 1.03%. And then for voltage measurement, we are using 5 number of cycle and 50 Hz fundamental frequency, and we display that the 413.8 and the total harmonic distortion is 2.87%. So from this we can conclude that the voltage and current for total harmonic distortion is less than 7%, which approve the requirement in the PBL assignment.
Hello and hi, my name is Amanda Zeta Anna Henry with number matric AE20029. So I will explain about design and calculation analysis. In our simulation, complete list voltage source interval 3-phase equivalents are displayed. We use 3-phase voltage source with controllable voltage, amplitude, phase, and frequency. Using SPWM technique, 3 sine wave and a high frequency triangular carry wave. 3-phase DC or the AC voltage source inverter are widely used in motor drive, active filter, and unfair power flow control in power system and uninterrupted power supply to generate controllable frequency and AC voltage magnitude. As explained earlier, both of switches in the same leg cannot be turned on at the same time in order for the circuit to satisfy the KVL and the KCL, because doing so would shorten the input voltage and weaken the KVL. As a result, the two switches in the same leg have complementary nature. In accordance to our simulation, switch AD, we can define that as AD plus S switch AE equal to 1 will be equation 1, as switch BD plus switch BE equal to 1 also with equation 2, switch CD plus switch CE equal to 1, equation 3. Two of S switches that represented in the table above result in output AC line voltage of 0. The AC line current is current in the simulation freely recycled through the upper or lower component. There are no 0 AC output line voltage in the remaining state. The inverter alternated between states to produce a certain voltage waveform. The result AC output line voltage are therefore made out of the district voltage value negative VDC, 0, and VDC, positive VDC. The modulating technique which ensure the instance of only the valid state is used to select the state in order to generate the supply waveform. So we can see VDC divided by 2 SAD minus switch AD minus switch AE equal to V voltage AN plus voltage NO. So will be equation 4, 5, and 6. From this equation 4, 5, and 6, in terms of the Malaysian signal, making use of the condition from equation previous equation, which is equation 1 and 2 and 3, give us the equation 7, equation 8, and equation 9. From this equation 7, 8, and 9, we can combine it with to be a total, so that it will be equation 10. By assume VAN plus VBN plus VCN equal to 0, we can make the equation 4, 5, 6, and 10 becomes, and combined become VDC divided by 6, multiply with 2 switch AD plus 2 switch BD plus 2 switch CD and minus V3 equal to V, and by substitute the V and O equation, 4, 5, and 6 give us this equation.